Okay, we're going to talk about a new model of the atom, a new way to model the atom. It works perfectly with Bohr models. It works perfectly with the atomic flower. It works perfectly with an Aufbau sequence because it is all of these things. This is our last way to model the atom, and it's called an electron level diagram or an energy level diagram. The gist of the energy level diagram is basically taking the atomic flower and making the atomic flower into a graph, okay? Making it into a graph. And there are two scientists besides Niels Bohr and Werner Heisenberg that really affect how this graph is gone, and that is Wolfgang Pauli and Hund, H-U-N-D. I don't remember Hund's first name. Okay. I'm going to draw over here to the side the atomic flower as I fill out this electron level diagram. Okay? Here we go. The first part of the atomic flower is an electron moving in an s orbital in one direction. We indicate that right here as an arrow up. Notice I'm drawing half of the arrow just to make it easier. Okay? All right. Okay. Now, this would be hydrogen. Boop, going in the opposite direction on that S. Now we got helium, right? If we were writing this as an Aufbau sequence, we would be at 1s2. Here is the second one. Now, Pauli said that these electrons are going to go in opposite directions and only two can fit per orbital. Okay? Now, if I move on, I'm going to write my 1s2 down here so I've got room. I need a bigger circle. That is lithium. And then on the opposite on that S is beryllium. So check this out. Lithium. And if we were doing an electron level diagram of lithium, it would just look like this. And here's beryllium, opposite. Notice, two electrons. Okay? Now, we're going to move on here to boron. Boron is a figure 8 or a p orbital on the x that wraps around the x plane. Guess what? This is a 2p. This is the x, right? And then here is the next electron. It's going to be flying in a p on the y. Now, a guy named Hund, Hund's rule says that it is more likely that this next electron right here that we just drew would be going on the y as opposed to going opposite on the x. Okay? So, boom. This is a model of carbon, an atomic flower of carbon. 1s2, 2s2. Now we're in the 2p's, right? Now this is nitrogen. It's going to be a p orbital on the y. And then the next one will come back opposite on the x. That would be oxygen. There's oxygen. Then we'll come back opposite on the y. That would be fluorine. Opposite on the y. And then opposite on the z, that would be neon. Opposite on the z, that's neon. So this is the atomic flower of neon. This is an Aufbau sequence. And this is an electron level diagram. Notice when we look at this, you can simply see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 arrows. So that's neon. Does that make sense? Now I'm going to stop drawing this, and I'm just going to go to the electron level diagram. This will be sodium, right? Magnesium, aluminum. Who's without aluminum? Silicon, phosphorus, and now I'm going to come back opposite, right? Who is, what we got? Is this sulfur, right? Chlorine, argon. Does that make sense? So if we stopped here, this will be an electron level diagram of argon. The only way you can miss these is if you start adding your arrows to a dash here. You got to go up, 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 and then down, down, down. It's hard to miss. Let's keep going. We're going to go up to potassium, and then calcium, and then now if you look at your periodic table, we've moved up to the D's. Now we've gone past calcium. Now we're in the D's. Scandium is in it's not 4D1, right? It's 3D1. So let's go back and look at the board that we have here. Let's go back and look at our board. Here's 4s2. This is calcium. Now watch. We have to go all the way over here. See how these dashes are actually lower than 4p? So then here's our scandium. Does that make sense? We're just filling these up by height. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. And then now here we are over to gallium, germanium. If I stopped right there, this would be an electron level diagram of germanium. If I wrote this as an Aufbau sequence, starting down here, I would write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is next. Now this is next. See how that's the next one up. 3d10, 4p2, germanium. What do you think about that? This is easy. To dumb it down as much as possible, add your arrows. Up, down, up, down, up, down, 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 up, down, up, down, 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 up, down, up, down, down, down. Just put the number of arrows on here that match the number of your element. And that's all there is to it. Cool.